Thank you for joining me today. Today, we will be discussing how batteries work. Batteries are portable sources of electrical energy that are found in everyday devices. There are two types of batteries, primary and secondary. Primary batteries are non-rechargeable and are discharged when the chemical reaction is complete. Examples of primary batteries include alkaline, lithium, and zinc-carbon batteries. On the other hand, secondary batteries are rechargeable and a chemical reaction can be reversed. Examples of secondary batteries include lead-acid, nickel-cadmium, and lithium-ion batteries. Batteries use chemical reactions to generate electricity. During this process, electrons flow through a circuit while ions move through an electrolyte. This creates a voltage, which is the difference in charge between the anode and cathode. Understanding how batteries work is crucial as batteries are used in many aspects of our daily lives, including powering electronics, starting cars, storing. In this slide, we will be discussing the composition of a battery. A battery is made up of four main components: the anode, cathode, electrolyte, and separator. The anode is the negative electrode of the battery, and it releases electrons into the circuit during the discharge process. The cathode, on the other hand, is the positive electrode of the battery, and it accepts electrons from the circuit during the discharge process. The electrolyte is a conductive solution that is responsible for allowing ions to move freely between the anode and cathode. It is essential in maintaining the charge balance in the cell. Lastly, the separator is a crucial component that prevents short circuits between the anode and cathode. It is usually made of a porous material that allows ions to pass through while preventing the anode and cathode from coming into contact. Understanding the composition of a battery is essential in understanding how batteries work. In the next slide, we will discuss the role. In this slide, we will be discussing the role of the anode in a battery. The anode is the negative electrode of the battery and is responsible for releasing electrons into the circuit during the discharge process. The anode is usually made of a metal or graphite, which are materials that can readily release electrons. As the battery discharges, the anode becomes negatively charged, and it attracts positive ions from the electrolyte. The release of electrons from the anode into the circuit is what generates the electrical energy that we can use to power devices. Understanding the role of the anode is crucial in understanding how batteries work. In the next slide, we will discuss the role of the cathode in a battery. We will be discussing the role of the cathode in a battery. The cathode is the positive electrode of the battery and is responsible for accepting electrons from the circuit during the discharge process. The cathode is usually made of a metal oxide or another compound that can readily accept electrons. As the battery discharges, the cathode becomes positively charged, and it attracts negative ions from the electrolyte. The acceptance of electrons by the cathode completes the electrical circuit and allows for the continuous flow of electrons, generating the electrical energy that we can use to power devices. Understanding the role of the cathode is crucial in understanding how batteries work. In the next slide, we will discuss the importance of the electrolyte in a battery. We will be discussing the function of the electrolyte in a battery. The electrolyte is a conductive solution that is responsible for allowing ions to move freely between the anode and cathode. The electrolyte is a crucial component of the battery as it maintains the charge balance in the cell. It prevents the buildup of charge on one side of the battery, which can lead to the battery failing. The electrolyte can be in liquid or solid form depending on the type of battery. The electrolyte's role is to facilitate the chemical reaction between the anode and cathode by providing a medium for the ions to move through. It is essential in maintaining the performance and longevity of the battery. Understanding the function of the electrolyte is crucial in understanding how batteries work. In the next slide, we will discuss the importance of the separator in a battery. We will be discussing how a battery generates electricity. The process of generating electricity in a battery is a result of a chemical reaction between the anode and cathode. As the anode releases electrons into the circuit, the cathode accepts these electrons, and ions move through the electrolyte. This process creates a voltage, which is the difference in charge between the anode and cathode. The voltage generated by the battery is what causes electrons to flow through the circuit, providing electrical energy to power devices. Understanding how a battery generates electricity is crucial in understanding how batteries work. In the next slide, we will discuss the importance of the separator in a battery. In this slide, we will be discussing primary batteries. Primary batteries are non-rechargeable batteries that are designed to be used once and then disposed of. Once the chemical reaction between the anode and cathode is complete, the battery cannot be recharged and must be discarded. Primary batteries are commonly used in low-drain devices such as remote controls, flashlights, and smoke detectors. Examples of primary batteries include alkaline, lithium, and zinc-carbon batteries. It is essential to dispose of primary batteries correctly as they contain harmful chemicals that can damage the environment. Understanding the difference between primary and secondary batteries is crucial in understanding how batteries work. In the next slide, we will discuss secondary batteries. In this slide, we will be discussing secondary batteries. Unlike primary batteries, secondary batteries are rechargeable batteries that can be reused multiple times. The chemical reaction between the anode and cathode in a secondary battery can be reversed by applying an external electrical current, allowing the battery to be recharged. Secondary batteries are commonly used in high-drain devices such as smartphones, laptops, and electric vehicles. Examples of secondary batteries include lead-acid, nickel-cadmium, and lithium-ion batteries. Secondary batteries are more expensive than primary batteries, but they are more environmentally friendly as they can be reused multiple times. Understanding the difference between primary and secondary batteries is crucial in understanding how batteries work. In the next slide, we will discuss the advantages and disadvantages of using batteries. In this slide, we will be discussing how batteries are charged. Charging a battery involves reversing the chemical reaction between the anode and cathode in secondary batteries. When a battery is being charged, electrons flow from the charger to the cathode, and ions move from the cathode to the anode. This process restores the chemical reaction in the battery and returns it to a fully charged state. It is essential to use the correct charger when charging a battery to avoid damaging the battery or causing a safety hazard. Overcharging a battery can lead to the battery overheating or even exploding. Understanding how batteries are charged is crucial in ensuring the safe and efficient use of batteries. In the next slide, we will discuss the advantages and disadvantages of using batteries. In this final slide, we will be discussing the common uses of batteries. Batteries have become an integral part of our lives and are used in various applications. The most common use of batteries is powering electronics such as smartphones, laptops, and other portable devices. Batteries are also used to start cars and power other automotive systems. Batteries are also used to store energy from renewable sources such as solar and wind power. This stored energy can be used when the renewable sources are not available, providing a more stable and reliable power supply. Finally, batteries are used as backup power for emergencies, providing power during power outages or other emergencies. Understanding the common uses of batteries is crucial in understanding how batteries impact our daily lives. Thank you for joining me in this presentation on how batteries work. Hi, I just wanted to take a moment to say thank you for watching my videos and supporting my channel. Your comments, likes, and shares mean the world to me and inspire me to keep creating content. If you haven't already, please consider subscribing to my channel. By doing so, you'll never miss a video and you'll be helping me reach more people with my message. I promise to continue providing high quality and engaging content that you love, so hit that subscribe button and join our community today. Thanks again for your support, and I will see you in the next video.